Welcome everyone. Thank you for coming to today's lunch buffet. This is a virtual SAN buffet. My name is Ronson Rivera, Duncan Eppen, my long-lasted cousin. The reason why it's a buffet is because today you're about to witness, if you haven't seen it yet, a little bit of the best storage platform ever created. Dead serious. Today we're going to talk about building a stretch cluster with virtual SAN, which is a new feature that has been added to the capabilities of virtual SAN in this new release. So very quickly, I'll point out some disclaimers. There's some financial and lawyers people that are here probably making sure that I don't say anything that's not true. So we'll kind of get through that very quickly. Now we're kind of going to go over this agenda. We're going to have a brief introduction to some of the items we will cover today. We'll talk about some of the key requirements and some of the architecture components that make up virtual SAN and how do we actually get around to creating this stretch cluster configuration. Then we're going to go through a procedure where we're actually going to show you and walk you through the entire demonstration of creating and building a virtual SAN stretch cluster. Then we'll also cover some of the failure scenarios, which are some of the most important things you guys are probably interested about. And then we'll talk about how the system interoperates with the rest of the platform, which is probably one of the most powerful things about this solution, the fact that it interoperates with everything that works with within your infrastructure as it relates to vSphere. And then make sure that we will take questions at the very end. This is a recorded session, so please, if you have a question, raise your hand. Someone will come to you with a mic so your question could actually be recorded, and then we can answer it. So bear with us for that whenever you have your question and it's ready. So with that, let's get started. A small introduction to virtual SAN. So obviously, I think here is probably one of the places where we have the most use cases for stretch cluster multi-site scenarios. One of the questions that has come up quite often throughout the week, we kind of deal with it all the time, is, is a stretch cluster used for DR or is it used for business continuity or avoidance? And it could be either way. It depends on how you look at it, how you use it, what are your requirements, and what are the things that you're capable to do by implementing such solution. For the most part, these are some of the options that are available. We do planned maintenance, which could obviously be used for a lot of different capabilities in their solutions. You can also think about disaster avoidance. Being able to utilize multiple sites at the same time, not necessarily only when something goes wrong, but in order to avoid some sort of disaster. Another angle is also automated recovery. You will see an actual demonstration on how automatically a stretch cluster configuration comes back online within minutes, right? Without having to do just about anything. Basically, it kind of just works the way it does because the rest of the platform is powering some of the solution we do with vSAN here. So, what's the interesting thing about virtual SAN? So obviously we are expanding the enterprise capabilities in data protection of the platform, of this particular storage platform, to enhance some of the things we deliver in terms of a capability or a potential data service actually from the solution. Virtual SAN is based on an active-active architecture, which means there are two active data centers that are currently hosting VMs in your applications and running at the same time. This solution is based basically on something that you can use, whether it's the hybrid model of vSAN or the all-flash model of vSAN. Any flavor, any architecture, it works with either one. Very powerful when it comes to performance. One of the things that vSAN is able to deliver seamlessly is synchronous replication between those data sites. Because as you probably know, if you're aware of virtual SAN and have some knowledge of it, we do multiple writes to multiple places to make sure that your data is highly available and protected all the time. So these are some of the things that virtual SAN can actually deliver in this particular stretch cluster configuration. What we talk about in terms of virtual SAN, one of the key focus and points that we talk about that product, that solution, and that platform is being able to eliminate any single point of failures. As most of you probably know, when it comes to understanding what virtual SAN delivers in terms of availability, virtual SAN covers you everything from the disk to the network to the host to whatever it fails, any single point of failure eliminated. What this is now enabling is now allowing you to also introduce, as part of your failure requirement, introduce an entire site, an entire data center. And it acts and it behaves exactly the same way as you would expect it when you run a traditional virtual SAN cluster. In this case, you'll be able to scale out the cluster initially today, right? This is something obviously based on testing some of the things that we do with what we support. You'll have the ability to deploy up to 15 nodes per site. Meaning that when it comes to potential consolidation of virtual machines that will run on each site, we can have, imagine, up to 200 virtual machines per host. Do that times 15 on each site, that's pretty big. but there's some things we actually have to kind of think about, because some of the requirements that are needed here are going to be based on the type of networking capabilities that you can deliver, so it becomes very important. But from a scalability, being able to host and deliver the value that you, which is why you use vSphere and kind of bring along vSAN, which is having a lot of different types of virtual machines and workloads on these different hosts, it is still there. You'll be able to actually scale the system quite nicely. In terms of disaster avoidance and planned maintenance, there's a lot of things that are happening nowadays which is not necessarily related to a failure. Now there are more proactive solutions where you may need to transfer or basically migrate from one site to another as it is still online. It is not about failing, it's about avoiding a failure. And by being able to have a solution that can systematically and very easy transfer one of your data centers to another, it becomes a very ideal solution for some of these type of business requirements that are coming available with some of the demands that we have and we're seeing today. Whenever there's a site that's going to go on fire, that's not the only time that you need to have some sort of solution like this. Virtual SAN will enable things like a DR, but in this case particularly, we're talking about using 2 active data centers. But in the event you ever have to do some sort of maintenance, which happens many times, it's not just about a maintenance of a host in particular. We're talking about potentially performing maintenance on a data center itself. In those cases, you'll have some help. You could call Duncan maybe most of the time. He's kind of closer to you than I am. And he'll probably show up and help you with some of the cleaning process. But for the most part, we're taking some of the existing technologies that have been introduced to virtual SAN and expanding it so that you're not dealing with something completely new. Everything that we deliver with virtual SAN is around some of the capabilities that have already been in place. What we do is that we enhance them so that you can have better use and kind of introduce them to newer use cases, like here in particular. Virtual SAN is based on the concept of failure domains, which means that any one particular host within itself is a failure zone. When you build a virtual SAN cluster, right, all of these individual hosts are within its own fault domain, its own failure domain. When it comes to deploying virtual SAN stretch cluster, we build upon that logic. So what we do here is that we basically take the same concept when it comes to the minimum requirements in terms of the fault domain areas, which is in traditional virtual SAN is 3 nodes. Here we introduce 3 fault domains to apply the same sort of logic to the system, which basically all that it does is it allows you to group multiple nodes into one failure zone. Okay? With that, we're able to introduce and sustain a failure, which is a feature that we introduced in Virtual SAN 6.0, which is basically called fault domains. This way, you're able to sustain any given failure of the system and still sustain your virtual machines and continue running, unless the particular virtual machine or the host that fails is where the virtual machine is running. In that case, obviously, some of the HA capabilities kick on and your virtual machines come back online. When it comes to aligning to the stretch cluster and how we take that concept, well, we do that in a way where we introduce a witness concept. Our fault domains basically are based on data domains, if you want to call them per se. That's just another logical way of calling it. But the third fault domain is being introduced in the form of a witness domain. That is defined by some of the things you'll see here in a second, but it basically isolates and it delivers that same sort of behavior, that same sort of requirement of the 3 failure domains to form this virtual SAN cluster, which is a requirement. When it comes to this, you'll have the 2 data domains and a witness domain, and you'll see how the different domains behave and how some of these components and objects from an internal perspective behave and where they're placed, specifically based on that concept. Okay? Now, when it comes to this, we're able, as I said before, we're able to expand the availability capabilities of the platform. We're very strict and very serious about data availability and making sure your data is never lost, corrupted, or any way, shape, or form. So not only are we enhancing and introducing another capability to the system, but now being able to introduce site failures to the concept of failure domains within virtual SAN, it makes it that much more appealing for you to use as a potential solution for your stretch cluster scenarios. Now, when it comes to how this could be implemented, it's again based on the same 3 fault domains, very simple to use, very simple to configure. You'll see that here in a couple of minutes. Now, the witness fault domain is an interesting concept, because traditionally, when we define these failure domains, we tend to have places that we can actually run and utilize multiple virtual machines. But in a multi-site scenario, we're talking about active data centers potentially. In this case, you need 2. Whereas the third fault domain in the form of a data center could be placed anywhere. It is only going to be utilized as a witness. And the difference between that failure domain compared to the other 2 is that no virtual machine could actually run there. It is only utilized to provide quorum, to provide access to the event, to some of the witness files whenever they're needed. And it basically is utilized to store metadata changes of the cluster. Right? It's been strictly optimized to behave in that way so that we actually make the most use of the actual network configuration, the traffic of the actual solution. When it comes to designing or adding the availability tolerance to the system, as you probably know if you are familiar with Virtual SAN, which I hope, failures to tolerate equals 1 means you have 2 replicas of your data. We have 2 exact mirror copies of your data. And you can expand beyond the actual fault domain in the failures as you increase the number of hosts, the number of failure zones. Traditionally, in a normal virtual SAN cluster, you can have up to 4 replicas of your data, right? Where you can have 3 you can set the system to support 3 failures to tolerate. But that requirement there requires a larger number of nodes. Today, Stretch Cluster supports 3 failure domains, and therefore, failure to tolerate equals 1 covers any one failure of any sort within the system. Now that includes the site, specifically in this particular setting. It delivers automated failover. In the previous session I had today, we had a really good discussion about what happens in terms of managing a failure, dealing with a migration. And this is where Virtual SAN stands out the most, because everything is basically automated. It's the same functioning features that you use with vSphere and automatically fail over with HA. Things move along with GRS, and they work seamlessly, out of the box. This is things that are working directly out of the box for the system. Now, when you introduce those failure domains, you are introducing those concepts. If you want to go beyond the capability of configuring the multiple failures, particularly here, you won't be able to exceed 1 site failure. But that's something that obviously could be debated at a later time. But the same concept that you know and what you know today about Virtual SAN is still applicable to the way this system works. So Stretch Cluster will work, feel, and look, and it will be operated in the same fashion that you operate a traditional Virtual SAN cluster today. So let's look at some of the architecture requirements and some of the details. Very important. So there are some network requirements, there are some storage requirements, and some compute requirements. So you can see here very quickly that we depend on some of the feature capabilities that are available within vSphere, HA, DRS. So we'll cover some of those in details, and no one better than Duncan tell you the advanced settings and all that, which he'll cover, and not only cover them, but demonstrate them in detail so you can see how to actually apply these settings based on our recommendations. So let's look at some of the requirements here. From a network perspective, Virtual SAN has some pretty unique, not completely foreign to some of the requirements for multi-site stretch cluster capabilities. For those of you that are familiar and are using Metro, vPlex, and those kind of solutions, the semantics of here are very similar. So if you look at some of the requirements from a network perspective, we require 10 gig connectivity or greater, right, across the link, across the data sites. In terms of the latency, we don't really like to put distance-wise in terms of how to limit the system, but it's basically designed for a metro type of solution. But the requirement here, and it's a requirement, is 5 milliseconds round trip. Okay, Virtual SAN has that requirement. It could be implemented in any sort of network topology of your choice. Traditionally today, Virtual SAN is mostly deployed around layer 2 network topologies. But out of the box, Virtual SAN also supports layer 3 implementations for those larger environments that have such requirements. When it comes to the network aspect of the witness, it's a separate set of requirements, as you can see here in the slide. So when it comes to the connectivity to the witness itself, we have a requirement of 100 megabyte connectivity in this case. For the millisecond latency to the witness itself is 200 millisecond round trip. The difference here, folks, is that there's not that much communication going up to the witness, right? It's not being used for actual customer data. It's being used for metadata changes, as you'll see here in a bit. When it comes to sizing some of these requirements, we've provided some guidance on some of the values and how you go about calculating the capacity from a network perspective that you'll need to sustain your particular size of the environment. These are some kind of initial sort of numbers. We actually have some better, more well-defined, fine-tuned numbers that we actually will be publishing very soon, and we can speak about that later when we get questions. But these are some of the numbers just to give you an idea in terms of sizing, not a specific science per se, but there's some fluctuations, some changes that we can do there, but just something you can kind of take a look at to sort of understand. So let me cover a little bit about the witness. The witness is an appliance. The witness is an ESX host that is virtualized that we provide to you, and it will only be available through Virtual SAN or a different implementation of this solution, which we'll touch on later. Specifically here, this virtual appliance only stores metadata. I want to make sure we're very clear on that. There is absolutely no customer data. None of the objects or components that restore data will be stored in this particular appliance. It is an appliance that is designed to store witness objects and not virtual machines. It will not run virtual machines. We include this as part of the solution, which is something that you don't even have to license. Right? It's an appliance that you'll see and you manage it just like you manage every other virtual machine. It has some requirements that you will control based on the size of your deployment. You want to deploy 15 nodes per site, X number of virtual machines. It has a particular requirement so that it can store those actual objects. And by the way, for those of you that are familiar with Virtual SAN and some of the platform sort of limitations today from a scalability standpoint when it comes to objects, right? We probably, some of you that are using vSAN are well aware that the system has a 9,000 component limit. This appliance has been modified to quadruple that limit because the appliance has to actually store witness components for each site. So you'll cover it specifically when it comes to that particular implementation of the appliance here. So some of the requirements will obviously apply when it comes to sizing. This, we're talking about virtualized disks. So we have actually provided that, you can actually from the UI tag any one of the virtual disks as a caching device or a capacity device, which are some of the requirements that Virtual SAN has. The behavior of this is exactly the same way as it behaves when you build a Virtual SAN cluster and you configure it. Nothing is different. We've tried very hard not to change the workflows on how some of these things are done so that you can keep that same similar approach to configuring and managing the system. So one of the things that are out of the box, you'll see that the appliance will come in 3 different sizes. I think it's tiny, small, or large. But those are the 3 different sizes that you'll get. But then you'll be able to customize this. Here's some of the sort of examples of what will you need depending on the size of your deployment, depending on also each site. So when you see here 15 plus 15 plus 1, it basically means 15 nodes per site, and the 1 is the witness because you'll always need the witness, right? In this particular case, we're always going to be creating the 3 failure domains. So those are some of the minor requirements that we have there. And some of the things that we're working on is that based on the latency requirements and the way in which the system talks to this witness appliance, we see that you could potentially place this witness appliance not only in another data center, but potentially and eventually once we're done with our testing, you could put this appliance somewhere in the cloud, right? Because in this case, obviously the communication is just to validate and make sure that we have quorum, and in the event of a sort of failure, that system will be able to tell the host and control which one is on control, which one is not, and be able to behave in the same way and fashion as you know today with all the traditional stretch cluster multi-site scenarios. When it comes to some of the networking requirement specifics to Virtual SAN today requires multicast, right? We traditionally deploy Virtual SAN on a layer 2 type of network topology. When it comes to talking to the witness, now we introduce a different approach because the witness could actually be outside of that domain. And now for the witness, we don't require multicast, and you can also talk to the witness over L3. So the configuration becomes more appealing, a little bit more flexible to some of the ways in which you have to work with the system. Did you get cold, buddy? Wow, okay. Some of the read and write operations, as you see, require communication with the witness. I'll tell you exactly what communication and when those communication points happen. Because we only store metadata on the actual witness, the only time communication goes up that way is whenever there's a change in metadata update. You create a new object, you take a snapshot. Those are the only times when that object, or those objects within that particular appliance, are sort of contacted and utilized. The communication remains across the 2 data sites, right? That's where all your data actually resides, and that's what we basically focus on. When it comes to the network topologies that are supported, so initially when we released Virtual SAN on the 5.5 version, some of the customers that had really large enterprises wanted to introduce and implement and run virtual SAN over L3 networks, right? A complete layer 3 fabric. After an early fix in 5.5, we introduced support for virtual SAN over L3. But we also now carry that on since there's 6.0 release, and we have it also in 6.1. That enables the ability for any customer that has a requirement to run virtual SAN over layer 2 stretch networks, right? Or a completely routed fabric over layer 3. Now, there's one thing that I want to mention, and I want to make sure we're very specific on this. There is no product-specific dependency on virtual SAN for NSX, right? The network traffic for vSAN it's outside of an NSX type of solution, which a lot of folks somewhat interesting. When it comes to dealing with an L3 fabric implementation, you have to understand that you're dealing with multiple IP subnets. What happens in our traditional cluster scenarios? We have features that allow you to migrate workloads from one site to another. That means that the network IDs and the network IP addresses change. In an L3 implementation, things do become a little bit more complex because you now also have to deal with managing the IP information when your virtual machines move, whether it's an active migration or it might be a failure. If I come up on another site and I have a different IP scheme, your application is broken. So here, you either introduce any sort of solution that will allow you to manage some of these things, which could be some sort of MPLS, or to any of these solutions that allow you to do this sort of thing, but it's organic. So for me, basically the solution that kind of manages that very quickly is NSX, because it's comes within the same platform, the same management UI, and the value that we deliver with our solutions are enhanced by being able to manage everything from a single pane of glass. And that is extremely important, even though it might be something you may not be doing today, but it's very, very important because the management of this infrastructure is key. We want to simplify everything as much as we possibly can so that you can have a much better experience and results whenever something occurs. So when it comes to some of the policies that we can support, obviously I think I mentioned failures to tolerate is how vSAN determines what happens when something goes wrong. So failures to tolerate equals 1 derives from the fact that we're using 3 failure domains. Okay? If you wanted to have failures to tolerate 2, we would have to support 5 failure domains from a stretch cluster perspective, which means 4 active data centers. We're not there yet, but who knows? You can implement that in virtual SAN fault domains features for rack awareness, which gives you more failures to tolerate. You can increase your availability capabilities, but particularly with stretch cluster, we focus on having 1 site failure, but also covers you for everything else that fails within that infrastructure. The network, the disk, the server, whatever it is still 1 failure to tolerate. You will still have access to your objects in that case, right? Which is how we deliver the value that virtual SAN is actually being able to do that. We will be able to also have the system kind of correct itself whenever it's possible, when the sites come back up, whenever there's a failure, but you'll be able to still sustain that same sort of availability requirements that you would have. One thing that actually came up in a question today in our group discussion for stretch cluster was this. How do we manage and how do we deal with split brain behaviors? To handle this, we specifically introduced the concept of preferred sites. You'll see here in a minute when Duncan goes over the demo and walks you through it, how you'll have to choose and define logically a preferred and a secondary site. The reason that we do this is so that if there is a split brain type of behavior where the actual network connectivity between the 2 data sites is broken, someone has to claim control, right? And in that case, we'll be able to actually have all the failures, all the virtual machines and all your applications will fail over to the preferred site. But again, these are logical concepts that could be changed at any point in time whenever you want to, and it's not defined or driven by any physical constraint or any potential physical requirement or the infrastructure that you may have. Okay? Now, for the first time, initially here, something that is very unique. So there's been a lot of conversation and obviously in the talk around reference to data locality. And there's a lot of different solutions have different capabilities focusing on this type of behavior. And to be honest, for virtual SAN on its own, reference to data locality to us is within the cluster because we do not risk object placement, the placement of your data over performance in that case. Virtual SAN gives you more performance than you can possibly consume depending on the implementations that you actually deliver or configure. But it does make sense to use reference to data locality when it makes sense, when it's useful. It is a good thing to do it. The fact that you can get a performance benefit by accessing objects and data locally instead of doing it over the network, that's one. But being able to have access to that data for an availability standpoint, it's even more important. So for Virtual SAN Stretch Cluster, we've modified the system to leverage data locality in terms of sites, which means basically that all of your reads are going to go directly from where the VMs are running based on those data centers. So we will read locally from the cluster, from the portion of the cluster that's stored on a different site, so that we don't have to traverse reads over the network link, right? But in order to sustain and maintain the availability settings in the principles that we've instituted in the platform, we will continue to do the writes across. So that not only do you get the performance value you need locally, but you also have the benefit of having the availability in the event of a failure, right? With Virtual SAN, you have the sort of guaranteed approach of no data corruption, none of that sort of data loss access, because we write in synchronous to multiple places at the same time. It is a lot faster to recover in the event there was a failure because your data is already on the other side. We will read those components from wherever they're located once the VMs come back up, right? Those kind of decisions, those kind of principles make this solution stand out in a lot of cases, because that's the sort of behavior you need to have in an enterprise type of solution where you run your business critical applications on, right? You have to have that forward thinking here. So with that, I'm going to sort of hand it over to Duncan to walk you through the actual configuration of the system, something we put together so that you can actually see how this is done and you can understand the seamless sort of integration pieces of all the components that enhance Virtual SAN and how it works with everything else within the platform.
So before we get started, is anyone using any type of stretched storage today? So Mezzo clustering, VMC type of solutions? Show your hands. Okay, that's quite a lot of people. So all you guys know how complex it is to set up the storage part, set up the compute part. The compute part isn't really going to change, but I think the storage part that we will show you is quite revolutionary, because it's just as easy as setting up Virtual SAN, same methodology, same concepts applied to a stretched cluster, which I think is truly unique. So we're going to go over a couple of steps. We're going to configure the fault domains, which is the essential part of Virtual SAN itself, the stretched clustering aspect. We're going to define the witness host. We're going to create the disk groups on the witness host, and then we'll look at the health of the cluster itself. We'll look at some of the components of the cluster, where they are placed, and then we'll introduce a failure. Before we do, I will show you the environment itself. It was a pure coincidence, by the way, that this was Dell. It had nothing to do with the announcements of this week, although, you know, we're kind of lucky. So if there are any Dell guys in the room, make sure that our friends from Dell know about it.
We want free FX2s all the time.
So we had these FX2 systems in our labs. So 2 systems in our lab, quite unique systems actually, because they are these hyperconverged models, 2U units, 4 nodes in there, but it also has these switches included in those systems, which is pretty cool. So what we did is we created a lab which is partly based in Austin and the other part is based in Dallas. So let's switch over to the environment itself to look at, you know, what it actually looks like from a Virtual SAN perspective. Hopefully, majority of you guys have seen Virtual SAN so far, but we'll go over some of the configuration aspects. So first of all, what we're going to do is we're going to look at some of the configuration aspects of the cluster itself. So when I talk about Virtual SAN to vSphere administrators, I don't talk about the storage platform itself, but I talk about the fact that Virtual SAN is the extension of your platform itself. With that, I'm referring to the compute part, of course, because if you look at HA and DRS, for instance, which most of you guys are probably well familiar with, Virtual SAN is just an aspect of that as well. So it's just an extension of your compute platform, in my opinion. So let's look at DRS first. Well, first of all, what we'll do is we already have DRS enabled. We're going to look at some of the other components that are part of DRS, things like VM host groups and other aspects that you will need to configure. So as you saw, we had DRS enabled. We're going to have a look at HA. There are a couple of things you need to know about when you configure HA when it comes to a stretched environment. First of all, of course, it needs to be enabled. Otherwise, virtual machines won't be restarted. It's as simple as that. Secondly, there's one thing that a lot of people tend to forget. When you do any form of network maintenance, you see the option host monitoring up there. If you do any form of network maintenance in a stretched cluster or in a regular environment, make sure you disable host monitoring. Because host monitoring is the functionality that will start restarting virtual machines as soon as the network is gone. So make sure you disable that when you do any type of maintenance. So we're also going to look at some of the things like failure conditions and how we respond to certain types of failures. So there's a couple of things that you can do. First of all, of course, HA by default is going to restart your virtual machines when a host has failed. But also in case of an isolation, you need to be capable of taking a certain action when a host has been isolated. So for these types of environments, particularly in the case of Virtual SAN, our recommendation is to set it to power off virtual machines and restart them immediately. Now, if you look at the options that you have here, you have three options. The first option is leave powered on, which we wouldn't recommend. The other one is shut down, and the third one is powered off. In the majority of environments, you will see people using shut down because it will cleanly shut down the virtual machine. But in the case of an isolation of a single host, you can imagine that vSAN itself is not going to be useful anymore because vSAN is accessed over the same network as the network that HA is using to do all of the heart beating. So if the HA network is isolated, so is the vSAN network, and you won't be able to properly shut down those virtual machines, which means that you need to set this to power off the virtual machines and restart them instantly. There are also a couple of new settings on the screen which has to do with PDL and APD, which is the all pods down and a permanent device loss scenario. We don't support that today in vSAN. It's something that we're working on for a future release. Some of the functionality that's actually in there today doesn't really apply to vSAN either, so we need to make a couple of architectural changes to actually enable HA to work with vSAN in this particular case. There are also a couple of other things you will need to configure. First of all, admission control. I had a session on HA yesterday, and I asked a couple of questions around how people are using admission control, if they haven't configured or not, what kind of admission control policy they are using, and some people weren't using admission control, which kind of shocked me. Because admission control is kind of your guarantee that virtual machines will be restarted. If you haven't enabled admission control yet, make sure to go back or even just grab your laptop.
Do it from right here.
Do it from right here, because this is the only guarantee that you will have the virtual machines will be restarted if a failure occurs or if a host isolation occurs. If there are no sufficient resources available, HA can't restart those virtual machines. So admission control is the only option you have. This is also typically when the difficult conversations start with customers. So if you're one of our partners and you're trying to sell this solution and you want to set this to 50%, the majority of customers will say, hey, hold on, that's quite expensive. Now 50% of my resources are gone. Well, guess what? If you want to make sure that you can do a full site failover, you will need to make sure that 50% of those resources are reserved. So this needs to be set to 50%. Sure, you can set it to lower, but there's no guarantee that virtual machines will be restarted if you set it to 20% or you set it to 10%. So make sure you set it to 50%. Then, last but not least, there's also a couple of advanced settings. Now, typically I would tell people not to touch the advanced settings because usually there is no real reason to touch the advanced settings. But in this case, there are a couple of reasons to do so. If you look at the screen, I think there's a couple here that are really important. First and foremost is probably the DES isolation address. So we specify 2 isolation addresses, and these isolation addresses need to reside in both sites. The reason we do this is you can imagine if there's some form of site partition, right, and both the site 1 and site 2 operate independently from each other, but now a second failure has occurred, we need to be capable of actually pinging a local address to figure out what has happened to that particular host or what has happened to those particular virtual machines. So that's the reason why you need to specify multiple isolation addresses in these types of scenarios. Same applies to VPlex, same applies to metro clustering, so if you're one of those customers, you haven't done that yet, make sure you specify that secondary isolation address. On top of that, normally what we will do is when there is an isolation event, we will ping the default gateway. If for whatever reason the default gateway is which is only available in a single site, make sure you disable that. And you can do so using use default isolation address and set it to false. Fairly straightforward. There's a couple of other advanced settings in there, but we'll get back to those because they're actually in the UI as well as of this latest version of vSphere itself. So next we're going to look at some of the affinity groups. Ronaldson already explained some of the concepts around the secondary and the primary side, but this is mainly about data locality. Ronaldson explained what data locality is about, so I'm not going to go over that again, but what we actually did in this environment is we created 2 different sites. both of those sites will contain the hosts that are local to that environment. So in this case, we have Dallas and we have Austin, and we placed the hosts that are part of Austin in the Austin group and the hosts that are part of Dallas in the Dallas group. We did something similar for the virtual machine. So the key reason for this being is that during normal operations, we never want to see virtual machines migrating between Austin and Dallas, because if that occurs, then what you will see is that you will notice that, for instance, the read cache will need to be warmed up again. Because we already explained we have that concept of site locality. Caching happens locally within the site itself, so within the domain that you've specified. If the virtual machine migrates out of that domain, the cache will need to be warmed up. So there's a performance impact there, so we want to prevent that from happening. So we've created these rules. Now the one thing to keep in mind when it comes to these rules is that when you create these rules, these need to be shoot rules. And we've actually tested this in our lab multiple times, and one of my colleagues was setting this up, and for whatever reason, he selected the must rule option, and if your site fails, your virtual machines won't be restarted. Because what happens when you create a must rule, vSphere actually pushes those rules down to the HA configuration, and HA has a list which basically states which virtual machines can be restarted on which host. And guess what? If you create a shoot rule, the hosts that are not part of that shoot rule, or of the must rule, sorry, will not be part of that list, so that means virtual machines won't be restarted. So this is very, very important. This also applies to VMC configuration. So if you're a vPlex or a NetApp Metro customer, make sure you configure these as well. Last but not least, this is a new setting that has been introduced in 6.0, and it has all to do with restarting virtual machines while adhering to these shoot rules. So the key reason why you should enable this feature is because, as I've already explained, you have this concept of data locality, and when it comes to caching, you don't want to have HA restarting that virtual machine on a different side, or you have things moving around. You can keep everything locally, adhere to the rules. Virtual machines won't migrate after restart itself, so there's no cost associated. So make sure you configure this. So next we're going to have a look at the fault domains itself. So the fault domains are a part of the HA configuration. Of the vSAN configuration. We've already configured vSAN, which is fairly straightforward. You probably have seen it in one of the labs or one of the other sessions. But now we're going to create the stretch cluster itself. I just saw a bunch of hands around, people using VMware environments, so NetApp, EMC, or any of the other partners. I'm going to show you how simple it is to actually create a stretch cluster in vSAN. We're literally talking about a couple of clicks here. So we're going to create two sites. We've already shown you that we have the site called Austin and we have the site called Dallas. So we're going to create these in the UI. The preferred fault domain is going to be Austin. The secondary fault domain is going to be Dallas. The next thing we'll need to do is we'll need to select those hosts and make those hosts part of that fault domain. So in this case, we're going to select the 4 hosts that actually reside in Dallas, move them over to the fault domain itself, which is just a single click, and then we're done when it comes to creating those 2 fault domains. As you can see, fairly straightforward to set up, nothing really special that you need to do. Next, we're going to select the witness host. So in our case, the witness host is a virtual machine that we deployed on a different host in the 3rd site. So we select that witness host itself. As we said, a virtual machine. Only thing we'll need to do is grab the local resources, because we need to have some form of storage available locally where we can store those witness components. And that's basically it. So we click next, you see the summary screen itself. We see what we've defined, the multiple hosts that are part of Austin, Dallas, and the witness itself. We'll click finish, and literally within 30 seconds, a minute, you'll see that the environment has been fully configured end-to-end. And that's basically all that it takes from a storage perspective. Fairly straightforward. I think the only reason here why it's taking longer than it should is probably the web client. So it's not vSAN which is being slow, it's the web client. You guys are all familiar with that anyway. It's being recorded, right?
Yes.
Ouch.
Yeah.
That's fine. Said it. I know them and they know me, so that's okay.
You said it, not me.
So as you can see, the web client now shows the 2 sites, Austin and Dallas, with the external witness. Fairly straightforward. Took us a couple of minutes to deploy this. And it's, as I said, it's that simple. Now let's take a look at some of the other aspects when it comes to stretch clustering. Now we have these virtual machines, and of course these virtual machines have been deployed with a policy. As you can see on the right side, we have the VM storage policies, and it actually shows up as green, which means compliant. So in this case, when we've created this new environment, What needs to happen on the back end is that all of these objects which could reside in the same site need to be redistributed across multiple hosts in different domains. In our case, that means that one of the components needs to reside in Austin and one of the components needs to reside in Dallas. And as you can see, all of the components are active. One of them resides in Austin, the other one resides in Dallas, and of course there's the witness component, which is part of that witness virtual machine. Really straightforward. It actually did that automatically, so you as an administrator don't need to do anything when it comes to that. Those policies are automatically applied when it comes to vSAN itself, and that works literally within, well, depending on, of course, the bandwidth between what we're talking about, minutes or hours, of course, depending on the number of virtual machines. So next what we're going to do is introduce a failure. So we're going to fail the full Austin site and then see what happens in terms of the response itself. Those who are running a stretch cluster right now know that, when you introduce that type of failure, depending on the configuration that you have, in some cases you will need to types of command line options to actually do the failover, but in the case of Virtual SAN, it's actually fully automated end-to-end. As you can see, 4 hosts have failed. The virtual machines have come missing. When we refreshed the UI itself, when we actually had to speed this up because we were waiting for the web client to respond, so we cut out about 30 seconds. But when we refresh it, you can see that the virtual machines have already restarted. And the key reason for this being is that HA is doing the restart. So I don't know if people are using Site Recovery Manager, for instance. Any show of hands? Okay, a bunch of people doing Site Recovery Manager. If you do a failover with Site Recovery Manager, what you will notice is typically it doesn't take minutes to do the failover itself. It typically takes a long time, depending on the amount of LUNs that you have, the amount of virtual machines that need to be restarted. The key reason for that being is that all of those restarts need to be performed through vCenter Server. And vCenter Server has a limit in terms of how many virtual machines it can start at the same time. Now, if you look at HA is capable of restarting 32 virtual machines at the same time per host. So if you have 15 hosts, you can do the math. There's quite a significant number of virtual machines that can be restarted. And when we talk about a restart when it comes to vSphere HA itself, it's basically the instantiation of the VMX process. So when you click restart on the virtual machine, that's what we are talking about. We're not talking about the full restart cycle itself as you normally would do with Site Recovery Manager. So you start the first 32, the batch of 32 virtual machines. Literally 5 seconds later, the next batch of 32 virtual machines can be restarted on that same host. So it's extremely fast. The benefit of these types of environments as well when it comes to virtual SAN is that you're using flash and in some cases even all flash configuration, all flash as the front end in terms of caching, which means that it's also extremely fast when it comes to powering on virtual machines. Now, last but not least, we're going to have a look at some of the components because in the first screenshot or in the first section when we showed the virtual machine, you saw that it was compliant. Now the virtual machine actually shows up as non-compliant. Non-compliant in this case means that one of the components has gone missing. So if anything has happened to your site or a host or a disk even, then you will actually see that in the virtual machine screen itself, or there's also a list of all the virtual machines in the VM profile sections where you can see which virtual machines are compliant and which are not compliant. So you can easily identify which virtual machines have been impacted by this type of failure or the type of failure that has occurred. Again, you can also see this on the component level. So if you would go to the component screen, which is part of the monitoring section, you can also see that some of the components have gone missing, and we're actually going to do that in a second. So in this case, you will see that the Austin components will have gone missing. And next, I'm going to switch over to the other section to handle some of the other failure scenarios. So as you can see here, again, non-compliant. If we click one of the disks, you can actually see where it was placed from a site perspective, also from a host perspective. And you will be able to see which of the components have gone missing. In this case, it mentions that the component at the bottom, which was stored in the Austin site, has gone absent, which means that we don't know what has happened to it. Basically, full site failure or the network has gone missing. Yeah. I added this slide after a conversation I had with the Dutch customers, and I know the guys are in the room, so I'm not going to mention their name, I'm not going to point them out. But I think the one thing that's really, really important when it comes to stretch cluster environments that you test it end-to-end. Whether you're using NetApp, whether you're using EMC, 3PAR, IBM, or vSAN in this scenario, make sure you test the different types of failure scenarios that there are. There's a reason your company or the company you work for or do the engagement for has invested a lot of money in this type of environments. They're not cheap. So make sure you test all of the different scenarios. Disk failures, host isolations, partitions, you name it. Make sure you test those. If you look at the different type of failures that there are a couple of things which I think are probably most common. The first one I'm going to discuss is a network partition between the two data sites. So in this case, one of the sites, which is in this case the non-preferred site, is partitioned from the preferred site, which basically means the network connection between both of the sites has gone. So what's going to happen in this scenario? Well, you have the witness object, which actually sits in the third site, and a witness object will form basically a subcluster with the preferred site in this scenario, and the virtual machines that are part of the non-preferred site will be automatically restarted in the preferred site itself. So keep that in mind, that in this case, the virtual machines will be restarted. Now, the key thing here is that if you look at HA itself, if you look at the HA configuration, there's no way that HA can today power off the virtual machines that are running in the non-preferred site, unfortunately. So if for whatever reason your users still have a network connection to the non-preferred site, make sure you kill those virtual machines manually, because otherwise, potentially they could be accessing those virtual machines and still, doing any type of writes or whatever, changing data on hosts which can't be committed to a disk ever. So make sure you kill those virtual machines. Anyway, what I wanted to demonstrate with this one is that if you have virtual machines running in a non-preferred site, they will be restarted in the preferred site basically as fast as we've seen in the demo. It takes about 30 to 60 seconds for the virtual machines to be failed over. When it comes to a full site failure, more or less the same mechanism applies. When you have a full site failure, of course, from a vSAN perspective, what will happen is we'll see that a couple of the heartbeats has gone missing. So I think it's 5 heartbeats that will need to miss. So 5 seconds straight, 5 heartbeats have gone missing. HA or vSAN will inform the cluster something has happened, we need to start taking action. When that has happened, we'll form the subcluster again with the witness appliance, and HA is going to take action. Now, if you look at HA itself, it will be informed that the site has gone missing. There's a couple of files on the data store that it will use to do that, and it has something that we call a protected list. The protected list lists all of the virtual machines that were powered on, in this case in the preferred site, and HA will know it will need to restart those virtual machines, and will do the restart of those virtual machines again instantly, and it will do those at about 32 at the same time. So depending on the number of virtual machines you have, so if you have 1,500 virtual machines inside A, it takes about a minute or two before those virtual machines are restarted. The question, though, that typically comes up is, what happens when my witness fails? Because it's still, an object of virtual SAN itself. Well, the nice thing about a witness failure, or actually it's not a nice thing, but the good thing about the witness failure itself is that it doesn't impact your data. So if you have a witness failure, you can just replace the witness. You can introduce a new witness appliance. You simply deploy a new witness, you introduce it to the cluster itself, and those metadata objects will be provisioned to that witness itself. It is not going to impact the site. However, if for whatever reason, of course, you have another failure being introduced, then you start facing challenges. Those are things, though, that we're planning on solving at some point in the future. But I think the good thing here is to know that the witness is a virtual appliance, very easy to deploy. It takes literally minutes to deploy. So before we're going to wrap it up, Rollinson is going to end with a couple of interop slides.
And I'll be quick on this. So there was a great question today, which I tried to sort of address early. Is stretch cluster DR? It's not to me. Stretch cluster is an active site, but with virtual SAN, you have the opportunity to make it that post DR. In this case, virtual SAN is compatible with vSphere application and SRM, and it has an exclusive RTO allocation of 5 minutes, which is a decrease from what it used to be from 15 to 5 minutes. Obviously, when it goes from the target and the destination, the source and destination, our virtual SAN. So everything works very exactly the same cohesively, using vSphere replication as a source of replicating the data, and SRM as providing the orchestration engine. So now you can go within 5 millisecond a requirement on the network piece between data active sites to any sort of distance that you support within your RPO and RTOs as your DR site, which is basically, out-of-the-box supportability for virtual SAN and SRM, so it could be used as more than just stretch clusters. You basically get two solutions in one, depending on what your requirements might be. We're actually also going to have the same sort of behavior through VCloud Air. It's something that's it's in the roadmap to introduce that sort of same behavior so that you can have DR to the cloud to vSAN and from vSAN as the same sort of solution that you would have in your traditional data centers. Now, one thing that I think a lot of folks were interested in, how many of you are smaller, medium-sized robo business? Raise your hands. Let me see it. Okay, good. Because virtual SAN is enterprise. But just in case that you want to use it for the small environments, we've introduced support for robo, as we call the commercial robo, where there's a lot of stores that can have, companies that have a lot of remote offices. You can manage hundreds of virtual SAN clusters. Now we're introducing the fact that you can use 2-node clusters. 2-node clusters as a minimum requirement to build a virtual SAN for robo. The thing that comes into play here is the fact that we're utilizing that witness to serve that third fault domain as a witness process, and now you have the two active sort of same behavior of the stretch cluster. But this is obviously defined from a specific licensing cycle where things are in different SKUs. But either way, virtual SAN will now be able to support the same sort of management capability in the robo behavior and also give you the same availability requirements and settings that it delivers with the failure should tolerate 2 = 1. So very scalable, very flexible from whether you want to do it in a large implementation. A cluster can now be either stretch, it could be 1, 1 in 1, to 15, 15 in 1, or you have your actual robo implementations depending on how many sites and things you may have. But either way, this is the way it would work. The beauty here is that you're still using the same management interface. Everything will be managed exactly the same, and it's very easy to use, which is one of our biggest sort of accomplishment. Deliver a user experience which is simplified from the rest of the things we've done in the past. It's all about simplifying, consuming the resources and managing them a lot easier than they used to be, and that's what virtual SAN delivers above everything else. And with that, we'll open up for some questions. Remember that if you have a question, raise your hand. Someone will come to you with a mic, and it will take those questions starting now. So if anyone has a question, please raise your hand. You have a question? Yeah, you're next. I call you out if you don't ask questions. That's how I do it.
What happens if my first site, or if a site fails, and I know it's a long-term failure? How do I reprotect my data on my remaining site?
That is an excellent question. If you know it's a long-time failure, you are going to be at risk. Because the way you reprotect yourself is that you have to bring back that fault domain, that data center. So I think your question is going, you would almost like to have FTT2 at that point, which is what you asked in the other question. And remember, the reason why you can do FTT2, regardless of the number of hosts that you have within the site, and that's an excellent question, because if I have 15 nodes in one site, why can I do failure should tolerate 2? Remember that the difference here is that a fault domain, the concept of the fault domain in this particular case, is composed by multiple nodes. Whereas vSAN on its own, right, if you don't build fault domains, could do that, right? That's what you would have to have at least 5 nodes to do that. And in this case, if we were supporting 4 active data centers and 1 witness as a domain, in that case you will be able to do it, because you have this is depending on the failure domain concept, same thing. So you will be at risk in that particular scenario until you bring that site back up. But it doesn't necessarily mean that something else will go bad, but you are at risk. That is one thing that you have to deal with.
Yeah, one thing I want to point out is during our testing we actually ran into this issue as well, and what you could do is you could actually break down the stretch cluster environment, introduce new hosts, and then start building it out.
Exactly.
We actually filed a feature request for it, and I think the great thing here is that we have one of the VPs of engineering in the room, so she can probably speed up the feature request for us.
So yeah, that is
so thanks for that.
Yeah, and that is a great approach out of it, because the system is so flexible that the concept of failure domains, if you lost a data center and you can use it for time, yes, to achieve, we should totally blog about that. to achieve exactly what you want, break up the cluster and build the failure domains within that site to achieve exactly what you want.
You need to have the
excellent.
capacity available, otherwise you won't be capable of doing it, because you need to have capacity to start rebuilding those components somewhere else. So.
Well, good question.
Another question at the back.
Do you also have the requirement for the robo environment for the 100 megabit connection to the witness?
Okay.
So the connection to the witness in a robo environment is much smaller. And like I said, I think on the slide, did we have the 100 megabit in there?
No, it should be 1.5.
It should be 1.5 is what we've tested. But it depends also on the number of virtual machines that you have. And in a robo environment, we sort of look at having smaller number of virtual machines which communicate a lot less. So the amount of capacity bandwidth is much smaller. But we're actually going to deliver a more precise formula for that in a matter of days to per se. But the requirements are not the same in robo when it comes to the witness, and neither is the connection within the sites. Because obviously in a robo scenario you have 2 servers on the same site. So you could use a 1 gig connection, but the preferred is 10, right?
Okay. And another question, could you also run a fault tolerance machine on such a stretched cluster?
Can we say the support thing now? So for fault tolerance, SMPFT fault tolerance it is now supported on Robo. On stretched cluster, it's something we're still testing, right? It is not supported in stretched cluster, but in Robo it is.
So the challenge for stretched cluster environments, which is not particular to vSAN itself, any VMSC type of environment, so we're talking Metro cluster from NetApp, EMC VPlex, SMPFT is not supported as it stands today. That has to do with the latency and the amount of overhead that SMPFT will incur in those types of environments. So you will start noticing that the virtual machines will start slowing down if you have a 5 milliseconds latency between the source and the destination. The other problem you'll have with SMPFT, in my opinion, is that you can't really determine where the secondary virtual machine will end up. There's no way to place it in a VM host Affinity Group. So it could easily sit in the primary, both of the VMs could sit in the primary site, which kind of defeats the purpose. So we will also have a feature request outstanding when it comes to that, and the DRS team is actually looking into that today.
Thank you very much.
It's a great question.
Good question,
Yes, it's a 2-part question. In case of network partition, what if I don't want my VMs to be restarted? Is there an option for that? And the second question is, what about recovery? So when you have a network partition and then it is going to be fixed, so is there any automatic resyncing of the objects?
Yeah, let me take the first part of the question, you can take the second part. So when it comes to HA, there's the option within HA itself to define if virtual machines need to be restarted or not. So you can define that per virtual machine. You can even specify the order in which they need to be restarted, which more or less is the order in terms of scheduling. So if you set high priority or low priority, there's no guarantee that one or the other will be fully started before the other one finishes, but you can actually define that on a per virtual machine basis. So you can mention per virtual machine if it needs to be restarted. So if you have a test environment, sure, you can assign those virtual machines within HA to not be restarted. That's a very simple mechanism. What we will do though in the current release is actually register that virtual machine on a host that is up and running in the other side. So we won't restart it, but we will register it for you. So just in case you will want to restart it manually, you can actually do that manually as of 6.0. So that's part of the current release.
Into the second part, we synchronize automatically. So when it comes back up, we detect it and we sync. We bring back the machine back into full compliance, which is automated throughout the life cycle of the VM if anything ever fails. And I think that'll be it for us, folks. I think we're actually out of time. So thank you. Please fill out the survey if you get a chance. And thank you for coming. Nailed it.